Hello everybody, so today we will be entering chapter 7, which is on optics. So there are 9 subtopics in this chapter. Basically it is a combination of 2 chapters, so it have geometrical optics and physical optics. So the first subtopic is on reflection at a spherical surface. So this subtopic will be focusing on mirror. In this subtopic, you should be able to state and use the radius of curvature punya formula, which is R equal to 2F for spherical mirrors. Sketch the ray diagrams with a minimum of 2 rays to determine the characteristics of the image formed by the mirrors. Use this equation for real object. And lastly, apply the formula for magnification lah. Okay, so before we go on to the spherical mirror itself, we have to recall our prior knowledge, which is reflection. Okay, so reflection here is defined as the return of all part of a beam of light when it encounters a boundary between two medias. So basically, it is what we call as pantulan cahaya lah. Alright, so the angle between this incident ray and this refracted ray should be equal, and all three of this will lie in the same plane. Okay, so spherical mirror, there are 2 types of spherical mirror. One of it is concave and the other is convex. So concave is sometimes also called as a converging mirror. So this is converging mirror, whereas this one is diverging mirror. So concave punya mirror, they curves inward, so make sure you know how to identify which mirror is which one, and convex is the one that curves outward lah. Okay, right, so these are some of the terms used for spherical mirror. There are 6 of them, and the first one is the center of curvature, which is the center of the sphere. This mirror here is actually a sphere, and the middle part of it is known as the center of curvature. Next one, we have the radius of curvature, which is just the distance from the pole up till the center of curvature. Next, we have the pole or vertex. The symbol is V ataupun P, and it is the point at the center of the mirror. Next, we have the principal axis, which is just a straight line passing through the vertex and the center of curvature. And then we also have what we call as focal point and focal length. The focal point is uppercase f, whereas focal length is lowercase f. And it is where the incident rays converge to a point which is known as the focal point, and this is only for concave mirror. Untuk convex pula, it diverge away from the focal point, as if it is originated from the focal point lah, the incident ray. Okay, so how do you determine the point? For the focal point, it is midway between the center of curvature and pole lah. Okay, untuk nanti kamu punya sketching of ray diagram, you have to be able to determine where is the position of center of curvature and the focal point itself lah. Right, focal length on the other hand is just the distance between the pole and the principal focus, which is focal point lah. Focal point ni also known as focus. Right, so how do we calculate the radius of curvature? We're just going to use this formula given here, which is R equal to twice the distance between the pole and the principal focus, which is the focal length. Right, so now let's go on to the ray diagram. How do we sketch the ray diagram in order for us to obtain the image formed by mirrors? So first, let's look at the concave mirror. These are the steps that you need to do in order for you to get the image. So first, we have to locate the position of the object. Next, the center of curvature, and lastly, the focal point. So this one I've already did it for you, but in exam you have to be able to draw it yourself lah. Okay, so let's start by drawing the ray starting from the top of the head here, and then goes parallel with the principal axis towards the mirror, and it is reflected back through, going through the focal point. Okay, so if I were to draw that, it's gonna be looking like this. So it's just a sketch, you don't really have to measure correctly, but it's much better for you to do it that way lah. Okay, so again, from the top of the object, going through the focal point and being reflected back parallel to the principal axis. So it's gonna be looking like this. You should only do 2 rays I mean 2 rays is enough lah. Boleh juga buat 3, tapi 2 rays is enough for you to know where is the position of the image. Okay, so don't forget the arrows for the rays, and then just at the intersection here is where the image is gonna be lah. So if you want to also draw the line for this one, it's gonna be from the top of the head and then through the center of curvature and being reflected back to the center of curvature as well. So it's gonna be like that, right? But I'm just gonna focus on drawing 2 rays only, and the image is gonna be formed somewhere here. Okay, so how do I know if it's going downwards or upwards? Basically, let's just imagine this principal axis as your reference line. Anything that goes below this reference line will be pointing downwards, whereas if it's going to be upwards here, it will be pointing upwards lah. Okay, so ini adalah image. So kamu label nanti di sini kamu akan letak as I, which is the image lah. Right, so 2 rays are enough. And then after that, usually they will always ask you what are the characteristics of the image. Firstly, since it is pointing downwards and relative to the object, this is a different orientation. So what we can say is this is an inverted image. So this is inverted. And then what else do we know? We know that the image is also much more smaller than the object itself. So what we can write is we can say that the image is diminished. Okay, so write it as diminish. Next, one more characteristics of the image is since it is formed in front of the mirror, this is a real image. Okay, so how do we know if it's a real image? It is formed in front of the mirror. Okay, so itu adalah concave mirror. Now let's look at the convex mirror. The steps are basically the same. Just have to basically remember the steps ini lah. Okay, so again, let's do OPF. So it's gonna go from the top of the object being reflected as if it originated from the focal point, something like that. Okay, so always remember to draw a dash line for the lines that are behind the mirror. So just erase some part of that and then draw the direction of your arrows. These are gonna be here and this will be pointing here, right? Okay, one more rays. Right, so it's gonna be from again from the top of the head, sorry, from the top of the object, diverge, reflected back as if it originate from the focal point, and then just reflected back parallel to the principal axis. Oh, I forgot, this should be extended lah. Okay, so we're just gonna extend up till it intersect with the first line, right? So this is like that, this is that arrow, and then just do a dashed line here. Okay, right, so basically we've figured out which point are the intersection of the image. It is basically this one here. So this is the position of the image. Okay, so that is I, and then do the characteristics of the image lagi. So this is same orientation as the object, so it is what do we call that, upright. Okay, so this is an upright image. It is smaller, so again it is diminished, and then it is formed behind the mirror, so this is a virtual image lah. Virtual because it is formed behind mirror. Right. Okay, so these are the only two that I'll be showing how you do it. This, on the other hand, you have to do it yourself and submit when I ask you to lah. Okay, and don't forget to list down the characteristics of the image, and then let's look for the convex mirror. Okay, so basically the same pula. But yeah, so for the convex mirror pun kamu akan buat sendiri juga, list down the characteristics as well. If you know this, for the convex mirror, the ray diagrams are only it's the same as the previous one lah, tapi kamu akan buat sendiri di sini. Right, so let's look at the spherical mirror equation. So these are the equation for mirror. So ini adalah untuk kamu cari focal length ataupun object distance ataupun the image distance. This is for the radius of curvature. Okay, so image object distance is the one that goes up till the pole. Basically that is defined. Did I define that in the previous one? Okay, no. So object distance, U is the distance from the object till the mirror, and then V is the image distance from the image itself up till the pole, and then F is just the focal length, and then what else? That's basically it. And then we have a formula for magnification. So this is for us to know whether the image is going to be magnified or not, and then basically tells us the height of the image ataupun height of the object lah. Okay, so if it's much more greater than 1, it's telling us that the image is magnified. If it's less than 1, it is diminished, and if it's equal to 1, the image has the same size as the object lah. Okay, so make sure that when you are solving question, you have to always remember the sign convention for each quantities lah. Right, so I've summarized it down here for you. So we have positive and negative. Kalau U is positive, the object is real, and then negative is virtual lah. And then image distance, if it is at the front side of the mirror, it's gonna be positive, and it is telling us it is a real image. And virtual for negative. The focal length pula, kamu perlu ingat yang ni ya, sebab dalam question you have to know whether the focal length is going to be negative or positive, and that depends on the type of mirror. So if it's a concave mirror, it's going to be a positive focal length, whereas convex it's going to be a negative focal length lah. Magnification on the other hand is telling us whether the image is an upright image ataupun inverted. This is when you don't have to draw the ray diagram, but the question asks you what are the characteristics. You can do it by calculating the magnification punya value. Kalau dapat positive, maksudnya object tu upright. Kalau negative, maksud dia inverted lah. Right, so let's look at an example here. We have a woman which is 1.5 meter tall. So this is the object. So this is the height of the object, located 3 meter from a convex anti-shoplifting mirror. This is our object distance from the mirror. So this is U. The focal length of the mirror is 0.25 meter. So since the question already tells us that the type of mirror is convex and the focal length is 0.25, we have to add negative here because this is a convex mirror. Right, so we have to find the radius of curvature of the mirror. That is just R equal to 2F, and that is 2 times negative 0.25, which is equal to negative 0.5 meter. Next one, the position of a image is just asking about V. So how do we find V? Since we already have the focal length and the object distance, we can use the spherical mirror equation, which is 1 over F equal to 1 over U plus 1 over V. So rearrange for V ataupun just substitute directly the values. Don't forget to include the negative for the focal length. You will then get the image distance to be equal to negative 0.231 meters. So what does this negative tell us is the image is formed behind the mirror. Okay, next what do we have to find? We have to find the magnification. So magnification is M equal to HI over H naught ataupun negative V over U. So it depends on what information is available. Since we already have V and U, we are going to use this equation here lah. Okay, so that is negative 0.231 divided by the object distance, which is 3, and we get the magnification value to be equal to 0.077, which is less than 1. Okay, so next we have to calculate the height of the image. So that one we can use the magnification punya formula, hi over h naught, which is so we are looking for the height of the image, so that is just m times with height of object, and this is 0.077 times with the object, which is 1.5 meter tall, and we get the height of the image to be equal to 0.12 meter. Okay, lastly we have to state the characteristics of the image form. Usually you have to give at least 3 characteristics lah. Okay, unless mentioned in question. So first, what we can see is based on this image distance, it is negative, so this is a virtual image. Next, we can look at the magnification. Since this is a positive value, it is telling us that the image is going to be an upright image. Next, since it is less than 1, it is telling us that the image is diminished, so it is much more smaller than the object itself lah. Right, so that is the solution for example 1, and that is basically for subtopic number 1. So what you need to know is basically this page here, as well as sketching the ray diagrams and determining what is the characteristics of the image. Right, so that is all for subtopic number 1.